Hello viewers, welcome to the maths class in Prof. Bittaye's online digital classroom on part 3 of the topic sets. Today I will be dealing with two things. The first part would be Venn diagram and the second part would be operations on sets. Therefore, stay tuned, like the video, share to your friends and loved ones, and please follow this page if you have not followed yet for more videos. Now, let's look at the first part called Venn diagram. What is a Venn diagram? In mathematics, a Venn diagram is a picture or image that shows the relationships between different sets or group of things. A Venn diagram is also a simple way to visually compare sets and see their similarities and differences. Sets can be represented by any closed figure such as rectangle, circle, triangle, etc. Example, let's see, we have set A and the members of set A are 1, 3, 5, 7, and 9. And then set B, the members or elements are A, E, I, O, U. And then set C, the elements are, we have 10, 11, 12, and 13. Now, we can represent each of these in a Venn diagram. And remember, I said sets can be represented by any closed figure, such as rectangle, circle, triangle, etc. So I am going to use a rectangle to represent set A, circle for B, and triangle for C, so that we can see the Venn diagram. Therefore, we start with set A. So set A, I am using a rectangle to represent the sets in a Venn diagram form. So inside this rectangle, we now write what we call the elements of set A. Remember, in our last lesson on sets, I said the name of every particular set must be represented by capital letters. So this is why we have set A capital, set B capital, and set C capital. So now, if set A is going to be represented in a rectangle, the members of set A would be written inside the rectangle. And the members are 1, 3, 5, 7, and 9. And whilst you are writing the members, avoid writing them too close. For example, you want to write 1 and 3, do not write it in this way. That looks like 13. So they must have a space between them. Now, let's move to set B. Set B, I am going to use a circle to represent the members. Therefore, all the members in set B would be written inside the circle. A, E, I, O, U. Then set C, I'm going to use a triangle to represent the members of set C. That is set C. So the members should be written inside the triangle, which is 10, 11, 12, and 13. So we can see that each of these sets have been represented in what we call a Venn diagram. So this is why we said sets can be represented by any closed figure, such as rectangle, circle, triangle, etc. But in most cases, we use circle. So which means instead of using a rectangle or a triangle, we prefer using a circle. So which means set A, if I am to write it again, I can use a circle basically to represent set A. And the members are 1, 3, 5, 7, and 9. The same thing to set C, I can use a circle to represent set C. And the members are 10, 11, 12, and 13. So this is why we said in most cases we use what we call circle to represent the members. Each set is usually drawn as a circle, as you have seen. Now, the circles can overlap to show what the sets have in common, which is called the intersection. Which means sometimes when you are drawing these circles, which is the Venn diagram to represent a particular set or sets, the circles can overlap. They can cross each other. And that overlapping part is what we call what they have in common. We call it intersection. Let's take an example of that. Now, let's say I have set A still to be 1, 3, 5, 7, and 9. And now I have set B, and set B, the members are 3, 5, 7, 11. Now, when you look at set A and set B, they have something in common. And what they have in common is what we call their intersection. And when you draw both of them in a Venn diagram, they should overlap so that that overlapping part, you can indicate what they have in common. Now, let's see what they have in common. We can see 3 here, and there is also 3 here. We can see 5 in set A and 5 also in set B. We can also see 7 in set A and 7 in set B. So which means set A and B, they have 3, 5, and 7 in common. Now, when you are representing this in a Venn diagram, so what we should do is to make sure that the two circles overlap each other. So we have here set A, and then we have here set B. Now we can see the overlapping region between the two sets. Now this overlapping region, it's what we're going to use to record what both sets have in common, which is their intersection. And they are 3, 5, and 7. So therefore we can indicate they are 3, 5, and 7. Then the remaining part here, all right, represent those elements that can be only found in A. The same thing for B. What you have here are going to represent those elements that you can only find in B. Now, what are those other elements that you can only find in A, which are not part of B? They are 1 and 9. So that 1 and 9 is what we're going to write here, which is that part that is not part of the overlapping region. The same thing here. All right. Now, what other elements do we have and can only be found in B alone? We can see that it's only 11. So 11 would be here. Now, if you want to identify all the elements of A, it's very easy. Remember that this circle, whatsoever element it touches, is part of set A. Which means set A, the elements are 1, 3, 5, 7, and 9. And when you come to set B, the elements of set B are 3, 5, 7, and 11. So basically, this is exactly what I said earlier, that the circles can overlap to show what the sets have in common, which is basically their intersection. But parts of that circle that do not overlap show what belongs only to one set, which is like set A, 1 and 9 belongs to only set A, whilst 11 here belongs only to set B. Now, let me give another example of this set that has an overlapping region. If one circle represent, let's say one of the circle here represent students who like playing football, and the other circle here represent football students who like playing basketball, then the overlapping region here would definitely represent those students who like playing both football and basketball. So always remember that those students that like playing basketball and football would now be the overlapping region, which is the intersection. Whilst this portion would only record students that only like football, and this portion would record only students that like basketball. Now, when a universal set is involved, it is represented by a rectangle, while its subsets are represented by circles drawn inside the rectangle. So let's remember the last class we talked about universal set. To remind you again, what is a universal set? A universal set is a set where all other sets can be found. In other words, it is the bigger set or the umbrella set where all other sets can be extracted from. What about a subset? We also talked about a subset the last class. A subset means a set that can be found in another set, or a set that can be found in a bigger set. We call that a subset. Now, let's take an example. So therefore, we are still on that Venn diagram. And now I want to bring in a universal set with subsets and see how to draw the Venn diagram. Now, let's say we have the universal set, and the universal set basically has elements of 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then we have set A, and this set A, the elements are 1, 3, 5, 7. And then we have set B, and the elements of set B are 2, 3, 5, 7, 9. Now, in this case, we can see clearly that set A and set B, all their elements come from the universal set U. So if you look at all these elements of set A, they can be found in this set called the universal set, the bigger set. 1 is here, is there. 3, the same. 5, the same. 7, the same. If you also come to set B, all the elements of set B can be extracted from the universal set. 2 is there. 3, the same thing. 5, the same thing. 7, the same thing. And 9, the same thing. Therefore, we can clearly see that set A and B are both subsets of the universal set. Now, to draw this, the universal set would be represented with a rectangle. Like that. That's a rectangle. And this would be for the universal set. While set A and B would be represented with a circle drawn inside the rectangle. That is, I have set A and set B. And what have you seen here? An overlapping region between set A and set B, so that we can indicate what set A and B have in common. Therefore, let's first identify the intersection of set A and B, meaning what set A and B have in common, so that we can indicate it on the overlapping region. Now, what they have in common is, we can see 3, 3 is there. We can see 5, 5 is there. We can see 7, and 7 is there. Therefore, we write that under the overlapping region here, which is 3, 5, and 7. Now, whilst the remaining part of A, remember, just before we talk about the universal set, we said this remaining part will now indicate what you can only find in A and not in B, which is going to be written here, and is only one element, which is 1. Whilst the same thing for B. Now look at B. What you're going to write here are those elements that you can only find in B and not in A, which is 2 and 9. So we basically have our 2 and 9. What about the remaining parts of this particular rectangle, which is outside the circle? Now, the remaining parts of this rectangle, which is outside the circle, will now indicate those particular members that can be only found in the universal set, but not in A, neither in B. Because these other elements in A and B are part of the universal set. They are already there now. But the universal set has other elements other than these ones, which are not found in A and B, so we record it outside these, outside the circles, which is still within the rectangle. Now let's find out. Remember, the universal set is from 1 to 9. So we have 1 here, 2 is there, 3 is there, there is no 4 in the circle, then 4 would be outside here. We have 5, there is no 6, so 6 would be here. We have 7, there is no 8, 8 would be here, and then we have 9. So we can see that the universal set is complete, which is 1, 2, 3, 4, 5, 6, 7, 8, and 9. This is basically how we draw the Venn diagram that includes what we call a universal set. And we should remember that the points or items shown inside a Venn diagram represent the elements or members of the set, which is basically what we have seen here. These are the items, or we call it the objects. These objects or items, all right, that we have written in the circle as also inside the rectangle, they are called the elements or the members of the set. Now, note that a Venn diagram can be used to represent the number of elements in different sets, which means, again, the Venn diagram can also be used to represent number of elements. Remember the last time we talked about number of elements, like number of elements in the universal set, number of U. Number of elements in set A, that is number of set A. Number of elements in set B, number of set B. And this means to count how many elements are in each. So these particular Venn diagrams can be also used to represent what we call number of elements in a set, if not the actual elements. So let's try to remember that. Now, let's therefore move to the last part of this particular lesson. The last part of the lesson would be operations on sets. Now, let's look at operations on sets. Now, operations on sets. There are 3 operations on sets. The first operation is called intersection. An intersection, the symbol for intersection is this that looks like N. The second operation of a set is called union. And union is also represented by U. And the third one is what we call complementary. Complementary is apostrophe. Maybe we can remember apostrophe. That is what we call complementary. These are the 3 operations on sets. Now, these operations help to construct or create new sets from the existing ones. Let's start with the first one, which is called intersection. Although we have touched it a bit when we were talking about Venn diagram. In sets, intersection means the elements or members that are common to two or more sets. Anytime you have elements or members that are common in two sets or more than two sets, we call it intersection. We have just seen an example. That is, let's say now we have, okay, we are looking at intersection. So let's say I have set P, and the elements of set P are 2, 4, 6, 8, 10. And elements of set Q are, let's say I have 5, then I have 6, I have 7, and I have 8. Now, if you look at P and Q, they have something in common, which is called the intersection. Remember in the Venn diagram, we said the intersection becomes the overlapping region. So, what does P and Q have in common here? We can see clearly that P and Q, what they have in common is basically 6, 6, then 8. Look at it. 6 is here, 6 is there. 8 is here, 8 is there. So these elements or members that they have in common, it's basically what we call intersection. Now remember, like I said, the symbol for intersection is this, that looks like N. This is the symbol for intersection. So therefore, if I want to write P intersection Q, what they have in common would be written as P intersection Q in this order. This is P intersection Q, and then the elements would be written in curly brackets. And what are the elements? What do they have in common? Is 6 and what? 8. So basically, that is how to write intersection. Now, let's look at the next one, which is called the union. Now, union of sets means all elements or members from two or more sets without repeating any element. So therefore, anytime we talk about union, that's the second one, union. Union, it means all the elements in all the sets that you have without repeating any particular element, which means every particular element or member should only be written once. But at the end of the day, you are going to have all the elements in this set and in this other set written as one, but basically no member would be repeated. And what is the symbol for union? The symbol for union is U. U basically represent union. And therefore now, if I want to write P union Q, I am going to write P union Q. Then I write the elements in curly brackets, which means we are going to write now all the elements of P and Q without repeating any member. Now, let's write it down in ascending order, from the lowest to the highest. Now, if you look at these two sets, the lowest number is 2. So we have 2, followed by 4, then followed by 5. You can see 5 here. Then followed by 6. There is 6 here, there is 6 there, but we only write it once. Every particular member should be written once. Then we have next 7. So 7, followed by 8. But since 8 is here and there, we only write it once. And the next element, it's basically 10. Now, this is what we call P union Q, which means in these elements, you can have all the elements of P and you can also have all the elements of Q without seeing a member being repeated. Now, for example, if we want to look at the elements of P, we can see 2, 4, 6, 8, and 10. Whilst the elements of Q are 5, 6, 7, and 8. So, which means this union has both members of P and members of Q without repeating any particular member. Now, let's look at the last part. The last part is called complementary. 3, complementary. Complementary of a set. Complementary of a set. Now, if we talk about complementary of a set, means all the elements in the universal set that are not in the name set or the given set. Which means if you have a universal set and you have a subset of that universal set, when we talk about complement of a set, it means what is not found in that particular set or the name set. For example, A complement means what is not in A. B complements means what is not in B. Therefore, the symbol for complement is apostrophe. We can all remember apostrophe. Apostrophe is basically the symbol for complement. It can also be written as C, a small c at the top. For example, set A complement, or it can be written as this, set A complement. That's a small c. So both of them represent complement. But the most commonly used one is this apostrophe. So remember that complementary means what is not in that set, what is not in that name set, or what is not in that given set. Example, let's say I have set A, and set A, I have members 1, 2, 3, 4, 5, 6. And then set B, and the members of set B are, let's say I have basically 3, 5, all right, 7. Now, if I write basically here, A complement. A complement means what is not in A. If I write B complement, it means what is not in B. Now, if you look at these two sets, we can also see that all the elements of B can be found in A. Therefore, A becomes the universal set, whilst B becomes the subset. So, B complement, therefore, means what are those members that are not in B? What are those members that cannot be found in B? And those members that cannot be found in B are other members of the universal set other than these three. And they are 1, 2, all right, we have 4, and then next one we have 6. So which means B complement is basically 1, 2, 4, and 6. Because 1, 2, 4, and 6 cannot be found in B, but they can only be seen in the other set, or you call it the universal set. But what if I want to write A complement? A complement means what is not in A. And what is not in A here, we can basically see that it's going to be an empty set. Remember empty set? We open bracket and then close the curly bracket again without indicating anything. Or we can write O and cross it. Why do we say empty set? Because we can see that all the elements of B can be found in A. Therefore, A complement means what is not in A, there is no element that is not in A, because all the other elements of B can be found in A. This is why it's called empty set. But let's look at this time where we're going to have set P, and the elements of set P are A, E, I, O, U. And set Q, the elements are B, C, D, F. Now look at this. If I ask you what is P complement? P complement means what are those particular elements that cannot be found in P? You can see that all the elements of Q cannot be found in P. Therefore, P complement here would be the same as equal to elements of Q, which is going to be B, C, D, F. Whilst Q complement means what are those elements that cannot be found in Q. And those elements that cannot be found in Q here would be equal to elements of P, which is going to be then A, E, I, O, U. So basically, this is how to find what we call complement of a set.